In today's video, we're going to look at section 7.5, which looks at the variance and standard deviation of a data set or of a distribution. First of all, I want to look at the variance, and the standard deviation will then follow. The variance of either a data set or a probability distribution looks at how far your data points are away from the mean. Okay, so let's say that we had data points x1, x2 through xn, and I'm going to use an uppercase n here to show that these are all possible outcomes. Okay, so we're looking at a population, so I'll use a capital N. Then let's say that these have mean mu. Okay, and you could also say that they could have an expected value. So the expected value of the data set, of the outcomes. You could also phrase it as E of X as well, depending on whether they've decided to just go with a data set or whether they're actually going with a probability distribution, in which case each of these would have a probability attached to it. Okay, so if you're just looking at a data set, we're looking at the mean. If we are looking at a probability distribution for a random variable, it would be E of X. Okay, I'm going to use these two terms interchangeably. Okay. Then we're looking at the distance of each of these points, each of these outcomes in my data. I'm looking at the distance between that and the mean. That is what the variance is a measurement of. So naturally, we'd look at the difference between each data point and the mean. The problem with that is that because the mean is a central point, okay, we said with histograms it's a balance point, some of these differences are going to be positive, some of these differences are going to be negative. So trying to find a single value measurement where we've added all these together, etc., they're going to all cancel one another out, as some are positive and some are negative. So we know that we can't do that. So what I'm going to do is I'm actually going to square each of these terms. That will make each of these positive. Okay, so it's still a measurement of distance, it's just that now we have squared that value to make sure that they are all positive. Then, using those values, we find that the variance, we call it the variance of x, is going to be each of these multiplied by the probability of each of the data points and then adding them together. So like I said, this is just used as like a measurement of the distance that each data point is away from the mean. But because we have this problem at this point here where some of these are positive and some of these are negative, we can't just add them all together and divide by the number of data points that there are, because when we add all of these together, then we are looking at them cancelling one another out. So in order to stop that from happening, what I'm going to do is square each of those values, and then I can go ahead and I'm basically finding the mean of the distance of each of the data points from the mean. Okay, so I'm finding an average of the distances that the data points are away from the mean. That's what the variance actually is. This is the variance for a probability distribution. So in the case when you are given our values k, I'll do this quickly in a table, you're given your different outcomes k, and you're given the probability that the random variable is equal to each of the outcomes. Okay, so when you're given a table like that, this is how I want you to calculate the variance. All it basically is a measurement of the spread of data. Okay, the larger the variance, it means the more spread out your data is from the mean. The smaller the variance, the closer your data points are to the mean. Okay, that's all the variance actually is. So whenever you are given a probability distribution like this, this is how I want you to calculate the variance. Take each of the outcomes, each of the data points, subtract the mean from them. So you will have had to have already calculated the mean like we did in the last video. Square that value, and then you're going to multiply each one by the probability of that outcome. I'm going to go ahead and do an example of using this. I'll use this table that I've drawn here. So my outcomes are going to be 0, 1, 2, and 3. And the probability of each of these outcomes is going to be 0.1, 0.3, 0.5, and 0.1. Okay. I want to find the variance. I will tell you now, in order to find the mean, exactly like we did last time, you're going to multiply each of the outcomes by its probability, and then you're just going to add them all together. So that mean is going to be 1.6 when you calculate that. So now the variance is going to be each of the outcomes minus the mean squared multiplied by the probability of that outcome. And you're going to add all of these together. And when you do that, you should find that this comes out to 0.64. Okay. There is another way of doing this, which can be slightly easier, especially if you've got a ton of data points. Okay. And that is that we can find the variance of x by looking at the expected value of x squared minus the expected value of x, so the mean, all squared. Okay. Like I said, this is helpful when you have a ton of data points. How do we do this? Well, let's go back to our example here. Okay. I need to find the expected value of x squared. So when I take x squared, my outcomes are all of my original outcomes squared. So 0, 1, 2, 3 becomes 0, 1, 4, 9. And then each of my probabilities is going to remain the same as they were back here. So I don't have any negative terms where the negative and the positive outcomes are going to square to the same thing. If that was the case, you would have to add those probabilities together. So if I had a k is equal to -1 here, when I squared -1, it would also equal 1. So I would have to add the probabilities of -1 and 1 together to find the probability that x squared equaled 1. Okay, so bear that in mind. We did do that in a previous video, so just keep that in mind if that does arise. But here we've just got each individual value does square to something different. So the probability that x squared is equal to k in this case is just going to be my original probabilities. So I'm going to have 0.1, 0.3, 0.5, and 0.1. So then the expected value of x squared is just going to be each of the outcomes multiplied by its probability, now that I've done the x squared part. So it's going to be 0 times 0.1, that's still 0. 1 times 0.3, that's going to be 0.3. 4 times 0.5, that's going to be 2. And 9 times 0.1 is going to be 0.9. So that gives me 3.2. And we've already found that the expected value of x is 1.6. If you square that value, you should end up with 2.56. Okay, so now my variance of x is equal to 3.2 minus 2.56, which again comes out to 0.64. So it depends how you want to do this. This can be easier if you do have a ton of data points, because then you're not having to go through this long formula of taking each value minus the mean, squaring it, multiplying it by the probability, etc. It's not bad when you only have 4 data points like we have here. But when you have a lot more data points, it can be easier to do it this way. Next, I want to look at what is the standard deviation. The standard deviation is just the square root of the variance, and the way that we denote the standard deviation is just by sigma x, okay? And all it is the square root of the variance. What's the purpose of the standard deviation? If we go back to our formula for the variance, if we look at this, you will notice that we have squared each of these distances. Okay, so we've taken our original data points, subtracted the mean, and then squared it. When we have done that, the data point and the mean are going to be in one particular unit. Let's say we were looking at, for sake of argument here, average lengths. Okay, so I had a bunch of different data points that were lengths. I found the average length, the mean, and then I've got each of the lengths minus the mean. Okay, so I've seen how far away each of the lengths is from my average length. Okay, that's fine because that would still be in whatever measurement of length that you're in, but then we've squared it. So let's say that your original measurement was in inches. Okay, you've got your length in inches minus your mean in inches. You're still in inches. Until you square it, then you're in square inches. We're in a different unit of measurement. So the purpose of this standard deviation is it puts your measurement of the spread of data back into the original unit. Okay, because by square rooting this, we are back in that unit that we were originally in, let's say inches. Okay. So the reason for the standard deviation is because it still gives us a measurement of this spread of data, how far your data points are away from the mean, but now we are back into the same units that we were originally in for our problem. That's why it's used. So if we go to our previous problem here and we had to find the standard deviation, it would just be the square root of 0.64, which is 0.8. There is one other way that you can find this, which is a good check. For most of the problems that you are going to get, you can just do it one of the two ways that we have looked at here. You can find the variance either for a probability distribution, that is, either by going through our original formula, find the distance between each of the data points and the mean, squaring them, multiplying them by each of their probabilities, adding it all together, or you can find the expected value of x squared and subtract the expected value of x and square that. The other way that you can do this as a check is on a calculator. If you have your calculator, what I would suggest you do is to go into your calculator and put your data points in one list and the probabilities in another list. So let's say you put your data points in list 1 and your probabilities in list 2. You can do that under the Stat menu and Edit. The way that you find the variance and the standard deviation is if you go back into the Stat menu and go across to Calc. So you do Stat, Calc. Your first option is one variable stats. Okay. So when you are in one variable stats in your calculator, like I said, it is under the Stat menu and Calc. When you're in one variable stats, it will ask for a list and a frequency list. Your list is going to be your list of data points. So whatever list you've put your data points in, let's say list 1, that would be your list. Your frequency list is going to be your list of probabilities. So let's say list 2 that you put that in. When you do that and you go ahead and calculate, it will give you, it's I think about the 5th option down, it will give you the value of sigma x. It will give you the standard deviation. If you want the variance, you're going to have to kind of go backwards and square that value. Okay, so it will give you the standard deviation. It will not give you the variance though. So the variance you're going to have to figure out from the standard deviation. Basically just square it. Okay, if we square 0.8, we get 0.64 for our previous problem. So it will give you the standard deviation. It will also give you the mean. So it's also a good check for that as well. The mean is always going to be the top value. So whenever you do this, you can go ahead and use the first value for the mean, and then the fifth option down will be sigma x, which is the standard deviation. So that is also a good check if you want to do it on the calculator, but please make sure that you can use the formulas that we have just gone through. How about if we don't have a probability distribution and we are just looking at a sequence of data points? Okay, so we want, let's say that we have a whole sequence of data points, and this is for a population. We're not dealing with what's the probability of each one, etc., etc., etc. We just have a list of data points like you normally would. This is kind of backtracking to like simpler stuff. Let's say we had this whole list of data points. I don't know, whatever it could be. Going back to a previous problem we did before, you could be looking at all possible weekly sales for a particular car dealership. We're not just looking at a year's worth of sales, we're looking at all possible weekly sales the entire time that the car dealership has been opened. So we've got a whole population of data points, and there are n of them. And again, we use an uppercase n because we're looking at a population. And then these have mean of mu. In that case, how do we find the variance? You will, I'm going to bring this up now, you will also sometimes see the variance as this, sigma squared. Remember, we denoted the standard deviation by sigma or sigma x. So sigma squared would make sense to denote the variance. So just in case you do ever see that come up, it is used in particular for the variance for a population of data points. Okay. How do we figure out the variance? Well, all you're going to do here is do each of your data points minus the mean squared and add all of those together. Remember, we are not looking at any of them having different probabilities this time. We just have a complete list of data points. They have a mean. You find the average of the data points and then you divide it by the number of them that there are. So you are literally looking at what is the average squared distance. Okay. Whenever they ask you for the variance for a population of data points, that's all you do. Okay, we're not dealing with each one having a different probability this time. So we've looked at what happens when we are given a probability distribution for our outcomes. We've looked at what happens when we just have a list of data points and we're looking at the variance of those data points. What happens if you are given a frequency distribution? Okay, so this time, I'll draw out a quick table here. Let's say that each of your outcomes, so we've got our outcomes here, and we have our frequencies of each of our outcomes here. Okay, so your outcomes are going to be x1, x2, and I'm going to go down to xr, and your frequencies are going to be f1, f2, down to fr, where when you add all of these together, is going to equal the total number, which is going to be n. Okay, so when you add together all of your frequencies, you're going to get n. How do we find the variance in that case? Well, you're still going to figure out what the mean is, like we did in our previous video, and then take each of your outcomes, subtract the mean, square it, but then multiply it by its frequency before you add them together and divide by n. Okay, so the variance in this case is going to be x1 minus the mean squared times the frequency. Add all of these together for each of your R outcomes, and then divide it by the sum of the frequencies added together, which is going to be the number of things in your population. So n in this case is just going to be the sum of all of your frequencies, the number of things in the population. And the standard deviation, it is the same for all of these. You take your variance, however you figured it out for each one of your probability distribution, your just standard data points, or if you're given the frequency distribution, go ahead, figure out what that variance is, and then you just square root at the end, and that gives you your standard deviation. So the standard deviation, that never changes. It's just going to be the square root of the variance. It just depends on which type of problem you are given as to how you are going to go ahead and figure out this variance. So if you are given a probability distribution, you use our first formulas. When you're given a set of data points, you use our second formula, where we just added together the square of the distances of each of the points from the mean, and then you divide by the number of data points that there are. Or if you have a frequency distribution, you figure out its mean, then you find the distances between each of the outcomes and the mean, square it, but then multiply it by each of the frequencies, and then you divide that sum by the sum of the frequencies, okay, which would be n. What happens if instead, because I made a big point of this here where it was a population, what happens if you have a sample? Okay. If instead you have a sample, whether this be for just a list of data points or you have a frequency distribution, okay? For a sample variance, we actually denote it by S squared. Okay, so I used sigma and sigma squared when I was looking at populations for variance and standard deviation. I'm going to use S and S squared when I'm looking at sample variances and standard deviations. So S squared, which is just the variance again, if you're looking at a sample of data points, so you've got a sample of data points here, then you're going to do the same thing that you did before. You're going to take each of your data points, subtract the mean from it. Remember, the mean for a sample we denoted by x bar, and add together each of these differences squared, and then you're going to divide it by the number of things in your sample minus 1. You don't have to worry about why we're dividing by n minus 1. It's a pretty long explanation as to why, and there is a proof behind why that is that you don't need to know. I just want you to know that it's to do with being unbiased when you take samples. But there is more of a lengthy explanation and a proof behind it. You just don't need to know the whole proof. But like I said, in order to make the sample unbiased, they actually divide it by the number of things in the sample minus 1. So when you're dealing with a population, you just divide by the number of data points. When you're dealing with a sample, you divide by n minus 1, where n is the number of things in the sample. If you are instead looking at, again, a sample but a frequency distribution, it's going to work exactly the same way as our previous population variance did, where we look at each of the data points, we subtract the mean from it, and you square each of these for each of your R different outcomes. and then you divide by the number of things in your sample. So remember, the number of things is going to be all of your frequencies added together. So you're going to do F1 plus F2 plus all the way through to FR minus 1. So N here is just going to be the sum of those frequencies. So if you go back to your original table, it's going to be F1 plus F2 plus F3 all the way through to FR is going to be N, and then you subtract 1 from it. But the rest of it falls out exactly the same. So, moral of the story here. Finding the variance when you're dealing with data points and frequency distributions is going to be roughly the same, but you do have to make sure that you are aware of whether we are looking at a population or a sample of data points. If we're looking at a whole population of data points, you just divide by the number of data points that there are. If you are looking at a sample, it's dividing by the number of things in the sample minus 1. And it's to do with making sure that your variance is unbiased. Like I said, there is a longer proof. You just don't need to know that for this course. Going back to our calculators to make sure that we can always check these on a calculator. If you go back in and you've got your list 1 is going to be your list of outcomes or your list of data points. Your list 2, your second list, is going to be, previously it was the list of probabilities if we're dealing with a probability distribution. You could also use a second list if you need to write down the frequencies of each of your outcomes. Okay, so you can use that second list either to put probabilities in or to put frequencies in. Okay, once you have done that, you're going to do the same thing again and go into stat, calc, one variable stat. Your list, L1, is always your list of data points or your list of outcomes. Okay, so list 1 with a probability distribution is just going to be your list of outcomes. Same with your frequency distribution. It's going to be that list on the left that we had back here. That's what you're going to put into list 1. For list 2, if you're dealing with a probability distribution, you put your probabilities in a second list. If you're dealing with a frequency distribution, you put your frequencies into that list. If you just have a list of data points, you need to leave your frequency list blank. So when you go into stat, calc, one variable stats, that first option, your list is always your list of outcomes or data points. So you're always going to have something in list. If you're dealing with either a probability distribution or a frequency distribution, you can put something in frequency list. You can put in a second list, okay? Either your list of probabilities or your list of frequencies. If you are just dealing with a list of data points, like we had here, with either a sample or a population, you need to make sure that there is nothing in that frequency list. So you may have to clear that out. Okay, just click clear on your calculator when you're on that list for frequency list. Okay, and then you can go ahead and calculate. There are two different values I want you to look at here. There is Sx and sigma x. Your calculator will go ahead and figure out both a standard deviation for if you're looking at a sample and a standard deviation for if you're looking at a population. So if you are looking at a population, I want you to read off the standard deviation under sigma x. If you're looking at a sample, I want you to read off the standard deviation for Sx. So Sx is the sample standard deviation, sigma x is the population standard deviation. It calculates both for you because it's not sure whether you're looking at a sample of data points or a population of data points. So make sure that you read off the correct one if you are checking using a calculator. But it will give you the standard deviation. You will then have to square that to make sure that it matches your variance. Because remember, variance square rooted is the standard deviation. So standard deviation squared will be the variance, regardless of whether I'm looking at samples or populations. Okay, so whenever you go ahead and check, your list is going to be your outcomes list or your data points list. Your frequency list is going to be your list of probabilities in a probability distribution or frequencies in a frequency distribution. If you are just looking at a list of data points, don't put anything in frequency list. Okay? You go ahead and calculate. If you are looking at a sample, Sx will give you the standard deviation. If you're looking at populations, sigma x will give you your standard deviation. You then square each of those to get the variance that you are looking for. Okay, so I would always use the calculator as a check. Go ahead, especially if you've got a small number of data points, just go ahead and use the formula. Then you can double check on the calculator. So now you know what to do if you are looking at a probability distribution, or if you're looking at just a list of data points or a frequency distribution for samples and populations. Okay, and a big thing to remember, and I will write this down again just to make sure that we are all on the same page, the standard deviation is always, regardless of what we're looking at, these probability distributions, these frequency distributions, just a data set, is always the square root of the variance. Okay, every time. So make sure that you remember that detail before you go ahead and do these problems.